Hello everyone, welcome to the presentation. My name is M. Bhaskar-Reddy. Today I am going to present module number 15, IP static routing. In this module, you are going to learn about different objectives. The first one is 15.1 static routes. Here you are going to learn what are the different types of static routes are there, how to configure, how we are going to describe the command and syntax for the static routes. In 15.2, configure IP static routes. So you are going to learn how to configure IPv4 and IPv6 static routes. In 15.3, configure IP default static routes. Here you are going to learn how to configure the IPv4, IPv6 default static routes. And 15.4, configure floating static routes. So here you are going to learn about how to configure a floating static route to provide a backup connection. And 15.5, configure static host routes. So how to configure the IPv4 and IPv6 static host routes that direct traffic to a specific host. So these are the different objectives you are going to learn. The first one is 15.1, the static routes. Here you are going to learn what are the different types of static routes are there, what are the syntax, how to configure the static routes. First one is types of static routes. Where we can use the static routes? Only in small networks or in enterprise networks? The answer is you can use anywhere, okay, wherever it is required based upon the context. Static routes are commonly implemented on a network. This is true even when there is a dynamic routing protocol is configured. Okay, for example, in my network I am using dynamic routing protocol. It doesn't mean I don't want to use static route. No, you can use dynamic routing protocol, the combination with static routes also. The static routes where we can implement in which protocol is going to support. So static routes can be configured for both IPv4 and IPv6, but for both protocols the static routing is going to support. Next one is what are the different types of static routes. So the static routes are classified into almost like 6 basic types: standard static route, default static route, fully specified static route, floating static route, summary static route, and host static route. So totally these are the different types of static routes. But in the now we are in Cisco version Cisco curriculum version number 7. In version 5 and version 6 we have summary static route, but in version 7 they removed this one. Instead of summary static route, they replaced with the host static route. This is the new one in CCNA version number 7 in module 2. Now we are going to see the brief view of all the static routes. Very important diagram. Okay, I summarized and I designed like this one. If you know this diagram, you know this chapter, and everything is you feel more easy. Types of static routing. So I told you the static routing is going to support for both IPv4 as well as IPv6. It means you can configure for IPv4 networks as well as IPv6 networks. So this types of static routing is classified broadly into 1, 2, 3, 4, 5, 6 types. First one is the standard static route. The second one is default static route. The third one is fully specified static route. Number 4, floating static route, or one more name, backup static route, summary static route, and host static routes. Okay. Now we are going to see one by one. Okay. The standard static routes are classified into 2 types. Okay. The first one is recursive static route or next hop static route. Okay, but now in this curriculum they are using mostly the next hop static route. That is the name. Okay, there is one more name for next hop static route is recursive static route. Okay, in the second one is directly connected static route. So in standard static route, there are two types: recursive or next hop static route, as well as directly connected static route. What is the difference between these two? How we will configure, how we will identify which one is next hop static route as well as which one is directly connected static route. For this, I am giving the hint here. Next hop, you know, hop means a router. Okay, next hop means next router IP address. That means gateway. Just for understanding, I am using the word gateway, but technically you have to learn the word next hop. Okay, so the point here is, in next hop static route, we are going to use the next hop IP address or gateway. The second one is directly connected static route. In directly connected static route, we are going to use exit interface. Okay, so like GG exit interface, G0/0 serial 0/0/0 like this one. Okay, so in directly connected static route, we are going to use the exit interface. Okay, please remember these two, because based upon these two basic logics, the remaining all protocols, all types are going to work. Okay, so the standard static routes are two types: recursive or next hop static routes, and as well as directly connected static route. In next hop static route, we are going to use the gateway or next hop address. But if we go for a directly connected static route, we are going to use the exit interface, right? This is the first one. The second one is the default static route. In default static route, we can use either next hop address or exit interface. See here, in default static route, if you want to use next hop, yes, you can use it. Or if you want exit interface, you can use it. But it is depends upon the question. For example, the question says configure directly next hop default route. That time you have to use next hop. For example, the question says configure directly connected default static route. That time you have to use exit interface. Okay, so which one you have to use, next hop or exit interface, that is depends upon the question. Okay, next one is the fully specified static route. In fully specified static route, the name itself indicating fully means we are going to use both next hop as well as exit interface. Okay, so next hop and exit interface, both we are going to use in fully specified static route. But in packet tracer, we cannot configure, because the packet tracer is not going to support for fully specified static route. In real device, yes, you can do it. Okay, the next one is floating static route or backup static route. It means what? Floating static route, one more name is backup static route. In floating static route or backup static route also, we use the same logic. We can use either next hop or exit interface. For example, configure next hop floating static route. That means you have to use the next hop, means the gateway address of the router. For example, the question says configure directly connected floating static route. That time you have to use exit interface. Okay, so which one you have to use again based upon the question. Okay, next one is summary static route. So but it is there in CCNA version 5 and version 6 curriculum, but here they are not mentioned. So but there is one type of static route. Okay, I'm not going to discuss about this one. But instead of this place, they are introduced the new type is host static route. Okay, so they removed here summary static route. Instead of summary static route, they replace this one with host static route. In version 5 and version 6, there is no host static routes. Okay, but in version number 7, presently you are studying, they introduced this one, host static routes. Same concept for host static routes also. You can use either next hop or exit interface. That is depends upon the question. For example, the question says configure the next hop host static route. That time you have to use next hop. For example, the question says configure directly connected host static route. That time you have to use exit interface. Okay, so that's all about, these are the different types of static routes. So you have to remember next hop means gateway or next hop router address. Directly connected static route means the exit interface. Very useful diagram. Please practice one time in paper. You will get more clarity and you feel more comfortable while going to the next slides. Next, how to configure the static routes. So if you want to configure the static routes, I told you the static routes is going to support for both IPv4 as well as IPv6 protocols. If you want to configure the IPv4 static route, we have to use the syntax is IP route. Okay. If you want to configure the IPv6 static route, you have to use the syntax is IPv6 route. These two commands you have to use in global configuration mode. Okay, so for IPv4 you have to use IP route. For IPv6 you have to use IPv6 route. So both these commands you have to do it. You have to configure in global configuration mode. Next one. This is the general syntax for any type of static route. That's why they mention general syntax. Now we are going to see for IPv4 general syntax. Means IPv4 static routes are configured using the following global configuration command. See here, in router you should be there in configuration mode. See, this is the keyword, or you can say this is the syntax IP route. Okay, this is for IPv4 networks. You have to use IP route followed by the network address. Okay, so followed by network address followed by subnet mask. So IP route, network address, space, subnet mask, space. Then the situation comes. See here, IP address means next hop address, or you can use exit interface. That is also one more option. Okay, so IP address means next hop address, and exit interface means that is what I discussed in the previous slide. Directly connected static route followed by distance. Okay, what is the distance is administrative distance. Okay, this is not mandatory to configure administrative distance for normal, but in special situation you are going to configure the administrative distance here. As you know, in my previous video I discussed the administrative distance value for the static route is 1. Okay, see the note, either IP address or exit interface or IP address and exit interface parameters must be configured. So you can use either this one or this one, or combination of both based upon the type of static route you have to be used. So this is the general syntax for IPv4. Now I am going for the IPv6 general syntax. Okay, so IPv6 static routes are configured using the following global configuration command. So the syntax for this one is IPv6 route space. See here, as you know, for IPv6 network there is no network and subnet mask. They replaced with prefix and prefix length. Prefix length means like subnet mask only. Okay, prefix means like full whole network. So the prefix value means the global unicast network with their prefix length. Okay, so in IPv4, as you know, there is subnet mask, network, and subnet mask. But in IPv6, not like that. You can write the whole network with prefix length. Okay, followed by same. This is from here onwards same. IPv6 address slash exit interface. Okay, it means IPv6 address means the next hop address or exit interface followed by distance. Okay, so here also distance means administrative distance. Okay, so these are the general syntax for IPv6. Okay, so before entering the next one, I want to recap what I discussed as of now. So the types of static routes are different types: standard static route, default, fully specified, floating static route, summary static route, and host static route. See here, if you go for standard static routes, there are two types: recursive or next hop static route and directly connected static route. In next hop static route, we can use the next hop IP address of the router, or we can say, just for understanding, route gateway. In directly connected static route, we are going to use exit interface. In default like floating and host or summary, we can use either exit interface or next hop address based upon the question. The last one is the fully specified static route, means it is the combination of both next hop IP address plus exit interface. This is the general syntax. For IPv4, you have to use the keyword or the syntax IP route network with subnet mask followed by either the next hop address or exit interface administrative distance. It is optional. Okay. And for IPv6, you have to write IPv6 route followed by the prefix with prefix length followed by the next hop address or exit interface followed by the distance. Okay. Right. Now we are going to see one by one. The first one is standard static route. In standard static route, there are two types. First one is recursive or next hop static route. The second one is directly connected static route. Okay. 15.2 configure IP static route. See here, the standard static routes are classified into two types: the next hop route or recursive static route. See here, in next hop means only the next hop IP address is specified. Okay, so that is what I told. The next hop means next router IP address, means the interface IP address. Or I told you, if you want to just remember easily, you can say gateway also. Next one is directly connected static route. In directly connected static route, we are going to use only the router exit interface is specified. Okay. Now we are going to see the syntax for the first one is next hop or recursive static route. How to configure it? See here. IPv4 static routes are configured using the following global configuration command for next hop or recursive static route. The syntax here: IP route followed by the network address followed by subnet mask. Then you have to write next hop address only. Okay, you have to write only next hop address, or you can use the gateway anyone. Okay, you can say, just for understanding, I'm writing gateway, but you have to technically you will say next hop address followed by the distance, means administrative distance. By default, I told you for all static routes the administrative distance value is 1. If you want, you can write. If you don't want, also not an issue at all. Okay, so the distance here, distance is optional. Similarly, for IPv6 static route, how you can write the IPv6 next hop static route or recursive static route is IPv6 route IPv6 prefix / prefix length, that is the whole network with prefix length, followed by same. You can use only the next hop IPv6 address, or if you want to use the gateway, no problem, followed by distance. Distance is optional. Okay. Now we are going to learn the syntax. Now very easy. Now I am going to give you one example for the next hop recursive static route. See here. See this diagram. From this topology, you will learn how to configure the recursive or next hop static route. See here, this is the dual stack network. First I am going to discuss about IPv4, then I will go to IPv6. The router R1 is connecting with this network 192.168.10.0/24 network, as well as this router R1 is connecting with the WAN interface, the WAN link here 10.10.10.0/30 network. Okay, and the router R2 is connecting with 192.168.20.0/24 network. In the last class, in the last video, I discussed what are directly connected networks and what are remotely connected networks. The networks which are directly connected with router, these are called directly connected networks. See here, for this R1, this is the directly connected network. This is 192.168.10.0/24, as well as R1 is directly connected with 10.10.10.0/30 network. So R1 contains two directly connected networks. Now, R1 doesn't know about this one, right? This is called the remote network. The network which is not directly connected, that is called the remote network. For example, if you see here, I am at R1, I want to reach this network. So 192.168.20.0/24. So from these two are directly connected. This one is remote network. So if you go here from R1, I am at R1, I want to reach this one, this network. I have only one remote network. So how many static routes you have to configure? That is the question. Okay. So based upon number of remote networks, we will write the number of static routes. For example, in this context, from R1, I want to reach this network. Means I have only one remote network. From R1, we have only one remote network. So we have to write only one static route inside the router number R1. For example, suppose I am at R2. Okay, these two are directly connected networks. Okay, this network is directly connected. This network is also directly connected. R2 doesn't know about this one. So how many remote networks are there here? Only one remote network is there. So how many static routes you have to write? Only one. So number of static routes is equal to number of remote networks or remotely connected networks. Now coming back here, I am at R1. I want to reach this network. So we have only one remote network. So I will write only one static route. See the configuration. In R1, we have to go to global configuration mode. IP route, that is the syntax, followed by the remote network here, 192.168.20.0/24, that is the subnet mask, 255.255.255.0, followed by what? This is the one. See here, this is the 10.10.10.0/30 network. So only we can use possibly two possible IP addresses. The first IP I assigned for this interface, the second IP I assigned for this interface. The type of static route is next hop static route. Means I am at R1. My next hop is this one. This interface is 10.10.10.2. That is what? 10.10.10.2. Right? For example, that is what I discussed in the previous slides. R1 gateway. This one. Okay? For router R1, the gateway is this one. So the gateway address is 10.10.10.2. This is another method how to remember. Okay, so you can use the technically the next hop IP next hop address, or you can say the gateway address also. So for R1, the next hop address is this one, 10.10.10.2. Now we go for IPv6. Okay, so if we go for the IPv6 one, R1 is connecting with this IPv6 network global unicast address 2001:A::B:1 network, and I am using here this router 2 is connecting with 2 network, and in between R1 and R2 I am going to use 3 network. Okay, so 2001:A::B:1 network, here 2 network, and here 3 network. Now I am at R1. That is more important here. From R1, I want to reach this IPv6 network. So only we have one remote network. So I'm going to write here IPv6 route. This is the network 2001:A::B:2:/64. That is what prefix 2001:A::B:2. This is the prefix. See here global prefix. Okay, so global prefix, and this is the subnet ID 2. That is what we can say global. That is totally prefix slash the prefix length here is 64. Okay, so /64 is the prefix length, and is the total prefix value 2001:A::B:2:/64. So means the whole network followed by the gateway. So our next hop address for R1, if you want to reach here, the gateway IPv6 address is this one. So I'm going to assign for this interface is 2. So 2001:A::B:3, first IP assigned for this interface, and the second IP assigned for this one. See here 2001:A::B:3:2. 2001:A::B:3:2. So I assign here. Okay, so this is how you have to configure the recursive or next hop static route. The next one is directly connected static route. So now, what is the syntax for directly connected static route? Everything is same. In stop, next hop, we write only exit interface. See here, IP route followed by network address, subnet, that is remote network address, remote subnet mask, followed by the exit interface, okay, followed by distance, optional, okay. For IPv6 also same, IPv6 route, IPv6 prefix slash prefix length means the total network, and the exit interface we are going to use, the distance is optional, right? Now we are going to see same one. I'm going to use the previous topology for how to configure the directly connected static route. I am at R1. I know I'm connected with this network as well as this network. I don't know about this network. This network is called a remote network. From R1, I want to reach this remote network, right? So, how to write the static route? IP route, the remote network 192.168.20.0 slash 24 is 255.255.255.0. And see here, for R1, I want to reach here. This is my exit point. Okay, so this one we have to write. What is this interface? Serial 0 slash 0 slash 0. So I write here serial 0 slash 0 slash 0. So this is how you will configure the directly connected static route. For IPv6 also same, but the syntax here is IPv6 route. This is the remote network here from R1. So 2001 A colon B colon 2 double colon slash 64, and the exit interface here is serial 0 slash 0 slash 0. So this is how you will configure the next hop static route and directly connected static routes based upon the question. Okay. The next type of static route is the fully specified static route. As I discussed before, the fully specified static route is the combination of the next hop address as well as exit interface. We are going to use next hop address and exit interface. See here, the same topology. I am at router R1. I want to reach this network. So IP route 192.168.20.0 slash 24 means 255.255.255.0. In fully specified static route, we have to use exit interface. So for R1, the exit interface is serial 0 slash 0 slash 0 followed by the next hop address. So for this one, for R1, the next hop address is this one 10.10.10.2. So 10.10.10.2. Similarly, for IPv6 also same. IPv6 route, this is the remote network here. 2001 A colon B colon 2 double colon slash 64. This is the whole network. Followed by the exit interface serial 000, and the next hop address is 10.10.10. Exit interface is serial 000, and the next hop address for IPv6 is 2001 A colon B colon 3 double colon 2. So like that, you have to configure the fully specified static route. In fully specified static route, there is one special situation there. As a next hop address, we can use link local address also. See the point here. In IPv6, for example, R1, the next hop address is this one, 2001 DB8 ACAD 2 double colon 2. Right? Correct? No problem. For example, I don't want to use this address. I want to use only link local address. It is also allowed. Okay. For R1, the next hop address is FE80 double colon 2. This is the link local address. Okay. See here. This is the R1 network. So I want to reach this is the remote network here. 2001 DB8 ACAD 1 double colon slash 64. The exit interface is serial 010 followed by next hop is FE80 double colon 2. So I am repeating. You can use either next hop address is the interface address or the interface link local address. Any one you can use. If you use any one, it is correct. So there is no issue at all. Okay. So the communication is successful. Okay. So that's all about the fully specified static route. Now, They are provided one dual stack topology. From this, you have to understand and you have to configure based upon the requirements. Okay. See here. Now we are going to practice this one in packet tracer. Okay. See here. First, understand the topology. There is a router R1. This is the one LAN network here, right? For R2, there is one LAN network here. For R3, there is one LAN network here. All these three routers are connected by the WAN links here. Now I'm going to check see one by one. For R1, the LAN network here is 172.16.3.0/24 network. For R2, LAN network is 172.16.1.0/24. For R3 LAN, 192.168.2.0/24 network. As well as the WAN link between R1 and R2 is this one, 172.16.2.0/24 network. As well as R2 and R3 WAN link is, we are going to use the network 192.168.1.0/24. So it is a dual stack topology. We are going to use the IPv6 also. So the global unicast address here is 2001 DB8 ACAD 3:/64 network. Here one network, 2001 DB8 ACAD one network. Here there is a different global unicast network here. So 2001 DB8 CAFE 2:/64 network. Here they are using 2001 DB8 ACAD 2:/64 network. Here 2001 DB8 CAFE 1:/64 network. So this is the basic network setup they are designed. Okay. So if you summarize this one, see here 172.16 one network, 172.16 two network, 172.16 three network. Similarly for IPv6 also, 2001 DB8 ACAD one network, two network, three network. Right. Now we go for here for between R2 and R3. See this one, 192.168 one network, 192.168 two network. These one and two networks. Okay, just understand the whole network. Okay, then only we go for configuration. You feel more easy. Next one is 2001 DB8 CAFE. See here. Okay, CAFE one network and two network. Okay, so CAFE one subnet and there is one network as well as two network. What they did in all these networks, the first IP I assigned here. So means 3.1 is the interface for this G0 giga interface here. The first IP here, the first IP of this one, 192.162.1. See the WAN links, serial 0102, serial 010. This is the WAN link. The first IP here, the second IP address of this one here. It means what? 172.16.2.1, 172.16.2.2. Similarly, if you go here, 192.168.1.0, it means 192.168.1.1 as well as 192.168.1.2, like this one. Okay, so they are assigned all this one. Even for IPv6 also, for example, 2:1, 2:2. Similarly, 2001 DB8 CFE 1:2, 1:1. Here also 3:1. Here also 1:1. Like that, I designed the topology. Now we are going to configure the next hop as well as directly connected static routes. How we are going to configure? We are going to see now. Okay. See here, what are the topology I discussed before? The same topology I pre-configured here. See, this is one LAN network. This is the other LAN network here. This is the other LAN network here. Okay. I already assigned the IP address for this one. Okay. If you check here, the IP address for this R1 is 17G00 interface is 172.16.3.1 and the IPv6 address is 2001 DB8 ACAD 3:1. So I'm talking about this LAN. Okay, so this LAN I assigned the first address of this network. Okay, it means 172.16.3.1 as well as 2001 DB8 ACAD 3:1. For the PC, I assigned the IP address is the fifth IP address for both IPv6 and IPv4. So go to desktop IP configuration. See here the IP address assigned 172.16.3.172.16.3.5. Subnet mask is 255.0 and the gateway address is 172.16.3.1. For this PC the gateway is this one 3.1. Similarly for IPv6 address also 2001 DB80 ACAD 3 double colon 5. So 2001 DB80 ACAD 3 double colon 5. The fifth IP assigned for the computer and the gateway address is double colon 1. That is what 2001 DB80 ACAD 3 double colon 1. The prefix length is /64. Remember, I am used the same IP addresses for means I'm going to take the fifth IP for IPv4 and IPv6 for all LANs for this PC as well as that PC also, right? So this is the IP address for this one. Okay. Now I configured this interface as well as this one. First I'm going to check whether there is a communication between this PC0 to R1 is successful as well as from R1 to PC0 also successful. Okay. So I configure this one. Next time I'm going to configure, I'm going to ping, I'm assigned the same. See here, this one also .5, the IPv6 address also .5, and this one G00 interface here is 172.16.1.1, and the IPv6 address is 2001 DB8 ACAD 1 double colon 1 means the first addresses I assigned here also. Now I'm going to check the communication between this LAN, okay, right? So I can ping from R2 to router is successful as well as from this PC to router also successful. Okay, so it means this LAN is also working perfectly. Okay, next one. Now I'm going to third one, R3 to PC2. So for R3, the G0 interface is 192.162.1, that is 2.1, as well as for IPv6 also CAFE 2 double colon 5. And the IP address for this one is fifth IP 2.5. Now I can ping from R3 to PC2 successful as well as from PC to R3 also successful. What I mean, it means all LANs here, this LAN as well as this LAN is working perfectly. See here, there are different ways to verify the interfaces, but in packet tracer, just for understanding, I showed like this one. But actually, you have to learn technically for troubleshooting purpose. You have to go enable show IP interface brief command. Okay, so you have to give what is the command? Show IP interface brief command. Press enter. See here. For this one, the G0/0 interface IP address here is I assigned 172.16.3.1, right? 3.1, and the method protocol everything is up. Okay, right. If you want to check for IPv6, same command show IPv6 interface brief command. Okay. So if you check for IPv6 interface brief command, you also check here G0/0, right? This is the command show IPv6 interface brief. Okay, G0/0. See here 2001 DB8 3 double colon 1 3 double colon 1. That is what I assigned. Okay, so there are different ways to verify all these things. Okay, now finally I am coming to the WAN links here. See here the R1 is connecting with R2. The interface here is serial 0102 serial 010. What is the network we are using for that 172.16.2.0/24 network? In this network, the first IP I assigned here, that is 172.16.2.1, and the second IP I am assigned for here 172.16.2.2. So just for clarity, this here I am assigned 1, for here I assign 2, just for my easy remembrance. Okay, if you want to assign here 2, here 1, no problem, no issue. Okay, but just for my understanding I assigned here. Okay, similarly for this one IPv6 2001 DB8 ACAD 2 double colon 1, the first IP here, and 2 double colon 2, the second IP I assigned for this interface. Okay, now I'm coming to this WAN link here, right? For this one, So the network is 192.168.1.0/24 network. It means the first IP I assigned here and the second IP I am going to assign here. And the IPv6 network 2001 BB8 CAFE 1:/64. So the first IP assigned here 1:1 and 1:2 I am assigned for this interface. So this is the basic network setup. Okay, if you have time, please design by yourself. Okay, it should be very useful. You feel more easy what you did like that. Okay, now we are tested. All LANs are successfully communicating with each other. Now I try to ping from PC0 to PC number 1. It is failed. I try to ping from PC1 to PC2. Failed. I try to ping from PC2 to PC0. It is failed. See here. We are communicating locally. Here also locally we are communicating. But if you want to communicate different local area networks over WAN link, we are failed. Why? Because this router don't know how to reach this networks like this one. So that is what I discussed in the previous video. Okay, in module 14. Okay, so in the router there is no routing table entry. How to reach this network? How to reach this network? How to reach this network? That's why it is failed. So what is the solution? The solution is either you have to use static routing or either you have to use the dynamic routing. So if you want to use, you can use static routing, or if you want to use, you can use dynamic routing. But according to here, we are going to use static routes. In next module, you are going to configure the same, almost same topologies by using dynamic routing protocols. But here we are going to configure the static routes. Okay. Now we learned the static routes are two types basically. Standard static routes is next hop static route and directly connected static route. Now I'm going to configure the static routes in R1. These static routes are next hop static routes. Okay, next hop static routes. Next hop static. I'm going to configure next hop static routes. So how to configure the next hop static routes? See the question. Okay. So how many static routes you have to configure? See, from R1, I know I am connected with this network, means this interface directly connected. This interface means these networks also directly connected. It means R1 knows about 172.16.3.0. This is connected network, as well as this is also connected network. 172.16.2.0. These two are connected network. R1 doesn't know about this network. This is the remote network, and this is also remote network. Okay. See the path from R1. See the question. From R1, I want to reach. From R1, I want to reach R2. This is the one. Okay. So configure the next hop static route to reach from R1 LAN to R2 LAN. Okay, that is the question, something like this one. Now, what is the path? The path is like this one. From R1, the data is going like this one here, right? So from here, I am here from PC0. I want to reach the R2 LAN, means PC number 1. So in this path, this router R1 knows about this network as well as this network, but this R1 doesn't know about this network. So this is one remote network for R1. So that is the first one. Okay. So from R2 to R1, we will get how many remote networks? One remote network is there. One remote network is there. Okay. Next one. I want to communicate from R1 to R3 LAN. Okay. So I want to communicate from R1 to R2 LAN. That is the first question. And the second one is from R1 to R3 LAN. Okay. So if you go for here, how many remote networks are there? That is the question. Okay. So just for understanding, just I'm going to hold here. Please tell me how many remote networks are there to reach from R1 to R3 LAN. Okay, right? If you want to reach from means here from R1 to this PC or PC0 to PC2, what is the path? Data is coming to R1, from R1 it is going to R2, R2 to R3, R3 to PC2. So the path is like this one, right? So in this path, R1 is connecting with this one and this one. These two are directly connected networks. But R1 doesn't know about this network as well as this network. So how many remote networks are there? Two remote networks. Why it is two? This R1, the path is from PC0, I want to reach PC number 2, right? So in this path, R1 is connecting with these two directly connected networks, but R1 doesn't know about this remote network as well as this remote network as well as this remote networks. So how many remote networks are there? Two remote networks are there. Okay, so there are two remote networks are there to reach from R1 to R3 LAN. Now I'm going to configure the static routes for both IPv4 and IPv6. Okay, so please understand the remote networks, connected networks. So if you are confused with this one, please go to my video number 14, the previous chapter module. I already uploaded in our material, okay, NetAcad account. Please go, and I discussed one topology. In that I spent almost 40 minutes. What is directly connected networks and what are the remote networks? Okay. Now I'm going to configure the static routes. What type of static routes? Next hop static routes. So from R1, how many static routes you have to configure to reach both PC1 and PC2? So from R1 to reach PC1, we have only one remote network. So one static route plus from R1, if you want to reach R2, because this is the path we don't know about this one and this one. So we will get two remote networks. So 2 plus here 1, totally 3 remote networks you have to configure. So first I'm going to configure how to configure it, IP route. So this is the remote network. 172.16.1.0/24 is the subnet mask. Okay, 172.16.1.0/24 means 255.255.255.0. See here, if you want to configure the static route, IP route followed by the network followed by the subnet mask. The question is, I want the next hop static routes. So in next hop static routes, we are going to use the next hop address, or we can say gateway address. From R1, the next hop is R2, means the gateway address is this one. Next hop address is this one, that is 172.16.2.2. So I'm going to write 172.16.2.2, right? So please verify. This is the network 172.16.1.0/24/24 means 255.255.0. From R1 to reach this network, this is the path, right? This is the next hop. The next hop address is this one, that is 172.16.2.2. Next one. That is the answer for the first one. From R1 to R2 LAN. How many remote networks are there? Only one. The next one is from R1 to R3 LAN. How many remote networks are there? Two, because the path is from R1 like this one. So there is one remote network here, one remote network here. So I'm going to write for this network first. IP route 192.168.1.0. This is the remote network here. /24 255.255.255.0. See the gateway. I am again here. Please remember, okay? I am at R1. I want to reach here or there. My gateway is same, right? I am at here. I can go like this one. I can go like this one. But my next hop is same, R2. The gateway address is this one, 172.16.2.2 only, right? Don't confuse. the gateway, the next hop is same next hop. See, I am here, I can go anywhere, but if I want to go anywhere, my gateway is same, that is 172.16.2.2. Last one, IP route. We have one more remote network here. We are going to configure this one, right? So this one is 192.168.2.0, right? 2.0. Subnet mask is 255.255.255.0. The gateway is same, 172.16.2.2, right? Okay. So this is how we'll configure the next hop IP address. Okay. For example, the question is configure the next hop IP address to reach from R1 to R2 LAN. This is the answer. Configure the next hop static route from R1 to R3 LAN, means this is the R2 static routes, okay, like this one. Okay. Now I'm going to configure the same thing for IPv6 also. See here for IPv6 networks, okay. So I'm going to write for IPv6 route. So if you want to write for IPv6, the syntax is like this one, okay. But the logic is same. One remote network here. There are two. Clear. IPv6 route 2001. Right. Okay. I'm going to just copy this one. This is the remote network. Okay. So I'm going to copy this one. This is the network. So 2001 DB8 AC81:/64 network, followed by, that is the IPv6 prefix with prefix length, right? That is the syntax. Followed by the gateway. For R1, the gateway is this one. That is 2001 DB8 AC82:: how much? 2. So I'm just copy this one also. Right? The gateway address here is 2001 DB8 2::2. Please. Most of the students are confusing here. What we have to do here? /64? No, this is a gateway or next hop IPv6 address, not the whole network with prefix length. Okay, so don't confuse. You have to write only the next hop IPv6 address only, right? Next one. I did for from R1 to R2 LAN. This is the remote network. Now I'm going for these two. So this network as well as this network. So I'm going to copy this one here. So IPv6 route. So I can paste here. Okay. So this is the network, because if you want to reach from R1 to R3 LAN, IPv6 one here. So this is directly connected. We don't know about this one and this one. That is, these two are the remote networks. Okay. So we'll get two remote networks, means two static routes, right? Now, so the gateway is same. That is 2::2. So this is the gateway, same gateway here. So Control-C, you can paste here, right? The last one is IPv6 route. IPv6 route, right? This is the network. I'm just copy this one. You can paste here. Okay, two network and the gateway is same. So like that, you have to configure the IPv4 as well as IPv6 static route. Okay. So now I'm going to configure everything inside the router number R1. Okay. So now I'm going to router number R1. Enable config. I'm going to paste all these static routes. See here, everything is perfect. Okay. So IP route for this first one, is the second one, is the third one. For IPv6 also is the first one, and this is the second one, is the third one. Okay. So in all cases we have used the next hop IPv6 addresses. Okay. So if you want to verify these IPv6 routes, going back, do the command show IP route. Okay. So if you do the command show IP route, you will see how many static routes you are configured. One, you can reach via, see here, your going to reach this network 1.0 network through the gateway is 172.16.2.2, right? Similarly, if you want to reach these two networks 1.0 network and 2.0 network, 192.168.2.0 network here. So 192.168.1.0/24 network, the gateway is same 172.16.2.2 and 192.16.24, once that is 2.2. So like that you can see here, if you want to verify the routing table entries, you have to check the command show IP route. Okay, for example, I want to check only static routes. Okay, yes, it is possible. Show IP route static. Okay, so show IP route static. So how many static routes you are configured in this router is totally how many? 3 static routes you are configured. This is how you will check. Show IP route static. You can verify like this one. But you can see here, but if you go for show IP route, you will get all connected networks and L for local networks, all these things. Okay, I discussed about what is C, what is L in the previous video. If you not clear, just go there. Okay, you will get the clarity, right? So this is how you will check this one. Now I want to check for IPv6. So if you want to verify the IPv6 static routes, show IPv6 route. Okay, if you check this one, show IPv6 route, you will see all IPv6 routes are here. Okay, so the command to verify the IPv6 routes are show IPv6 route. So this is the static route you write for this network. See here, ACAD1 network. What is the gateway? ACAD2:2, right? Similarly, you write for CAFE network as well as CAFE2 network also. Like that, you will verify all the static routes. Okay, so interfaces, everything. Okay, right. Now I did for R1. Now I am going for the next one is router number R2, right? Router number R2. In router R2, I don't want to connect next hop. I want to use the directly connected networks. Directly connected networks. Okay, I want to use the directly connected networks. See here. So if you go for the directly connected networks, we have to use the exit interface. Okay. So the question is, from router number 2, I want to reach router number 1. It means from R1 LAN, from R2 LAN, I want to reach R1 LAN network. So how many remote networks are there? Okay. How many remote networks are there? Okay, that is the question. Okay, so from R2 to R1, it means now I am at here, right, at this point. So from R2 means from PC1 to PC number 0, I want to communicate. See here, this R2 is connecting with this network, this network, this network. How many directly connected routes are there? 3 directly connected networks are there here. Okay, so 3 links, 3 directly connected networks are there. But our question is not directly connected networks. To reach from R2 LAN to R1 LAN, it means the path is like this one, from PC1 to R2, R2 to R1, R1 to PC0. So this is connected, this is also connected. Only one remote network is here, this one. Okay, so I'm telling again, read the question, from R2 to R1 remote network. Okay, so from R2 is from here to here, that is PC1 to this one, PC0, right? So only one remote network we will get. This is the remote network because R2 does not directly connected this one. Okay, but the network here 172.16.3.0. So I'm going to, so only one remote network here, right? The next question is, from router number R2, I want to connect to router number R3 LAN. Okay, so from R2 LAN, R1 LAN to, from R1 LAN to, I want to connect R3 LAN, right? Okay. So how many remote networks are there to reach from R2 to R3 LAN? See here. I am at R2. It means from PC1 I want to communicate to PC number 2. See the path PC1 to R2 or from R2 to R3 this one. Okay. So if you check here, R2 again directly connected this one and this one. These two are directly connected. R2 doesn't know about this remote network. So how many remote networks are there? Only one. Why? The question says from R2 to R3 network, LAN network. So R2 is connecting with this network as well as this network. R2 going like this one. R2 is not connected with this network. This is the remote network. So how many remote networks are there? Here is only one remote network is there. Okay. Now I'm going to write the answers for this one. So IP route. So from R2 to R1 means this is a remote network. 172.16.3.0, right? This is the remote network 172.63.0/24 means 255.255.255.0. What is the exit interface? See the question. The question says the directly connected static route. It means we have to use the exit interface here. For R2, the exit interface here is this one, serial 0, 1, 0, because the path is like this one from R2 to like this one. Clear? So I am at here, my exit interface is immediate here, serial 0, 1, 0. So the exit interface is serial 0/1/0. Right. Next one is from R2 to R3. From R2 to R3, we have also only one remote network. So this is 192.162.0. So I'm going to write for this one IP route 192.168.2.0/24 255.255.255.0. What is the exit interface? From R2, I want to reach this R3 network. From R2, my exit interface is this one, right? Because the packet is going like this one. Clear? This is the path. What is the exit interface for R2? To reach R3, serial 0/1/1. Okay. So serial 0/1/1, right? So there are two static routes to connect to reach R1 and R3 from router number R1. Now I'm going to configure these two in R2. So the direct connected static route means you have to write the exit interface. Okay. So please remember this one. Okay. Now I'm going to R2. So enable contiguity. So I'm going to paste these two here, right? So this one. Okay. See here. If you write the serial 010, you will get the message like default route with gateway. If not, point-to-point interface may impact performance, but that is the default exception. Don't consider this one. Okay, it is correct command only. Okay, right. So this is what I did for this one. Now I'm going to verify my static routes. Show IP route. Okay, so it is there. Yes, two static routes are there to reach two network as well as three network here. If I want to check only for static, show IP route static, right? So now we configured two static routes like this one, right? So now what I did for R1 to reach R2 and R3, as well as from R2 I configured how to reach this R1 as well as R3. Now I am going to configure R3. For that I am going to use the default route, right? Before going to configure R3, I'll go back to the PPT and we'll come back to the topology later. Okay. Now this is the topology we configured basically, right? The next topic here is 15.3. Configure the IP default static route. See here, where we have to use the default static route. In two situations, mostly we will prefer to configure the default static route. See here, for example, my router, for example, this is my organization. My router is connecting with internet. I don't know what is the ISP network. Okay, in that situation, I can use the default static route. Okay. The second situation here is, for example, this router R1 to reach R2 or internet, what we have only one link, that is called the stub link, or you can say stub router. What is stub? I discussed in the last chapter. Stub means we have only one entry and one exit. That is called the stub. So in that situation, we can use the default static route. In the scenario one, we don't know the remote network. We can use the static route, the default route, as well as the situation like stub route. We can prefer the default static route. The third case, for example, in the routing table, how the router will check how I will take the default static route. For example, some packet is coming to the router will identify the remote network. If there is no remote network in routing table entry, finally it will check the default static route. If the default static route is there, based upon exit interface or next hop, it will forward the packet. If you are not configured even the default static route also, the packet will be dropped by the router. Okay, so these are the different contexts where we can use the default static route. Now, default static route is a static route that matches all packets. Means a single default static route represents any network that is not in the routing table. Okay, default static routes are default static routes are commonly used when connecting an edge router to a service provider network. Okay, or a stub router, that is the second situation. Okay, so mostly we'll prefer in connecting the edge with ISP, your edge router with ISP, or in stub router situation means only one entry and one exit interface, that is called the stub network or stub router. Okay, in the situations we prefer the default static routes. Now, what is the syntax? How to configure the default static route? If you want to configure the default static route, the network is 0, the subnet mask is also 0. So this is the syntax for IPv4 default static route. If you want to configure IPv4 default static route, IP route followed by the network, because I don't know what the remote network, that's why I write the network is all zeros, as well as the subnet mask, I don't know, that's why I put all zeros. So the network is zeros, subnet mask is also zeros, but you can use next hop address or exit interface based upon the question. Now we go for IPv6 default static route. How to configure the IPv6 default static route? The IPv6 route, that is the syntax. See here, the prefix, if you want to put 0, you can put, but no need. Double colon slash, that is the prefix is no prefix here. Double colon slash, the prefix length is 0. So double colon slash 0, that is the IPv6 default static route. Okay, so IPv6 route double colon slash 0 followed by the next hop address or exit interface based upon the question you have to configure, right? So this is how you will configure this one. See here, one more name is called quad 0 route. Okay, that is also called the default static route. An IPv4 default static route is commonly referred as quad 0 route. Okay, this is the one more name. Okay, so what is important here? In IPv6, the remote network, like we don't know what the remote network is, that situation, the network value should be 0, the subnet mask value also 0, as well as in IPv6, we'll write double colon slash 0 like this one, right? Now we are going to see the example here, how to configure the default static route. Same diagram here. R1 is connecting with this network and this network. From R1, I want to reach ISP, but I don't know what is the remote network here. In that situation, I don't know the remote network, I don't know the remote subnet mask. In that situation, I can write IP route. The remote network is 0000, the subnet mask is 0000, like this one. Okay, so in the situation, we can write like this one, right? Or like stub route also, yes, you can do like this. Okay, so IP route. So 0000, because I don't know the remote network here, the subnet mask was 000, and I can use either exit interface or next hop address, that is serial 000 or 10.10.10.2 any one. Okay, this is how you will configure the IPv4 default static route. Now we go for IPv6, how to configure it. IPv6 route /0. This is the default IPv6 static route. Okay, followed by exit interface or the next hop address, that is 2001 AB 3:2. So based upon the question, you can use either this one or that one. Okay, so that's all about the default static routes. Before going further, I'm going back to my topology. I want to configure here. Now we are going to test how to configure the default static route. Okay, see, now I am at router number R3. I want to configure, see the name, directly connected. Okay, directly connected default static route. Default static route. So the question is configure directly connected default static route. See here, directly connected is the keyword, default static route is there. So which one you have to use, next hop address or we have to use the exit interface? Directly connected means exit interface. Okay, now see, the context here is from R3 I want to reach R2, right? As well as from R3 I want to reach R1, right? See here, from R3 I want to reach R2 LAN network as well as R3 LAN network. Normally R3 is connecting with this network and this network. R3 doesn't know about this network. This is one remote. So to reach from R3 to R2, this is the path. Okay, so one remote network is here. From R3 I want to reach this one. There are 1 and 2. There are totally 2 remote networks are there. The point here is I don't know what is the remote network here, what is the remote network here, what is the remote network here. If that is the case, we can write the default static route. So now I'm going to configure the default static route. So how to configure this one? See here, IP route 0.0.0.0 network 0.0.0.0 subnet mask. See here, why I write this one? This network means any network, even this one or this one or this one. Any network it means, okay? Any network, if you want to specify, you have to write static route for 172 network, 172 2 network, 172 3 network. But I don't want to write for all these things. I just simply I can give any remote network. That is the meaning. Clear? That is 0002 0000. That is network and subnet mask. The question is I have to use directly connected or exit interface. Okay. For example, so directly connected means exit interface. From I am at R3, my exit interface is this one, serial 011, right? So serial 0/1/1, that is my exit interface. Okay, so serial 0/1/1, that's it. Okay, now I write for this one, same exit interface. I write for this one, same, because for example I write for this one IP route 0000 and exit interface is same. That's why no need to write again. For example, see here, I am writing this static route. Imagine from R3 to R2 means this one, right? This is the default. If I write, I'm going to write for this one, right? So I don't know about this remote network. That's why I write 000 same. And I don't know about this remote network. Also IP route 000 like this one. So all answers are same. That is the meaning. Okay. No need to write 3 default static routes. All are same, because if you write for this one or this one, because you are not specified as long as the remote network, everything is zeros. No need to specify again 3 times. Okay, so that's why I'm going to write only one. means from R3 you can reach any remote network, but the exit interface is serial 011. Okay. Similarly for IPv6 route /0, that is what I told. So if you want to configure the IPv6 route /0 and exit interface here is serial 0/1/1. Okay. So this is the IPv6 static route. Okay. So this is the prefix with prefix length is 0, and this is the exit interface serial 0/1/1. See here, from R1 I want to reach this IPv6 network. Yes, you can reach this one. Yes, this one. Yes, like this one. Okay. So that's all about this one default static routes I'm going to configure in router number R3. Right. For example, the question is next hop means you have to give R3. This next hop is 192.168.1.2 like this one. Okay. But the question says directly connected means exit interface serial 011. Right. So I'm going to paste these three in R3. See here, enable config 2. I'm going to paste these two. Right. So I configured two default static routes. Okay, one for IPv4 as well as one for IPv6. I want to verify. Show IP route. Yes, it is there. One static route, because see the star mark, it is default static route. Okay. Now you want to verify again. Show IP route static. Yes, it is there. Okay. Only one static route. So this is the remote network with subnet mask value, and the exit interface is directly connected. That is the meaning serial 010. Now I'm going to check for IPv6. Show IPv6 route static is there. Okay. Show IPv6 route. See here, /0. This is the one. Via this is the exit interface. It is directly connected. Okay. Now we reach the full topology configuration. We have configured the next hop in R1, directly connected static routes in R2, and default static routes in R3, like this one. Okay. Now we are going to test. We are able to communicate with everyone or not. So PC0 to PC1 is successful, and PC1 to PC2 successful, as well as from PC2 to PC1 also successful. So all IPv4 you are able to communicate. Now we are going to check for IPv6. So for IPv6 I'm going to open the command prompt and ping to where. Okay, I want to ping to PC1 IPv6 address. Okay, so I'm going to copy this one. Right, I can give here paste here. Okay, so 1:5, right? ACAD, for example, you can test here. Okay, for 3:1, right? It is working. 2:2, 2:2, right? 2:2. So we'll check the static routes here in R1. DVDC 2:2, right? So CAD1 network, CAD1 network, 2 network. So everything is clear here, right? Now we'll go for this one. Enable. Okay. Okay. For R2, I didn't configure this one. Okay. So for R2, where is this one? Okay, we missed this one. Okay, so for R2, we didn't configure the IPv6 routes. Okay, I'm going to configure IPv6 route. So from R2, I want to reach R1. Okay, so this is the network, right? So I'm going to paste this one. This is the network and the gateway. The gateway is I am at R2. I want to reach here. This is my entry. That is 2001 DB8 AC2 double colon 1. Right. So I'm going to copy this one. I'm going to use this IP. So 2 double colon how much? This is 1. Right. Okay. So this is the first one. The second one is IPv6 route. IPv6 route from R2 I want to reach R3 LAN, means this one, right? So I can write this network and here how much? This network, okay? From R2 I want to reach this network, right? Okay. This network, what is the gateway? 2001 DB8 ACAD 2 double colon 1, right? Okay, 2 double colon 1. So from here I want to reach this network, CAFE2 network, right? Okay. And the gateway is this one, copy this one, right? Paste it. So these are the two IPv6 routes. From R2, I can reach R1 network. From this is the one for from R2, I can reach R3. That is 3 network as well as 2 network. Okay. So now I'm going to configure these two static routes in R2. So Control J configure, right? So I think this one. I think this one. Not this one. What type of static routes? This is directly connected, right? So I have to give this one exit interface, okay? Not next hop address. This is serial 0/1/0, right? For this one is here serial 0/1/1, right? Okay. So for this is the exit interface for to reach here serial 010, serial 010. Now I'm going to delete these two static routes, okay? So I'm going to route that R2. So no this one, all right? No IPv6 route, okay? No IPv6 route. Okay, so now matching a route 2 double one 1. See, okay, this one. Show run command. Okay, we check for IPv6 routes here. Yes, this is clear. Now I'm going to paste these two directly connected static routes. Okay, so 3 double colon slash. Okay, right. So config. So I'm configured two directly connected static routes from R2 to R1 as well as from R2 to R3. Now we'll try to ping for which one? Yes, it's working for 2 double colon 2. It's working, right? Okay. Now I'm going to ping for this IP6 address. Okay. So Control C. Go to the PC. Ping for how much? This is one. ACAD 1 double colon 5, right? 1 double colon 5. Yes, it is working. Okay. You are able to ping successfully for this one. If you want to try to ping for this one, okay, I want to ping from here to this one. So I can open ping to, right? It's working. Okay. So everything is working. Like that, you have to ping, for example, from this PC, I want to ping for PC number 3 from PC2 command prompt, for example, ping to this one. Yes, this we are working. Okay, same. So from PC1 IP address, for example, here, this one, I want to ping to PC from PC2. I want to ping PC number 1. Okay. So ping to PC number 1. See, you are going to ping everybody. Okay, so this is how you have to configure the IPv4 and IPv6 recursive, or you can say next hop default routes, as well as um, directly connected static routes, as well as default static routes. Okay, based upon the question you have to view. But here I configure default static route just for understanding. Okay, in exam, yes, you can. Not if there is no ASP, the question is default. You can write just default. Okay, there is a communication is there. Okay, so that's all about this activity. This is what we discussed. Okay, default static route like this one. Okay, the next one is configuring 15.4 configure floating static routes. Okay, the next step is configure floating static routes. See here, the floating static routes, one more name is called backup static routes. See here, very important. Okay, just you have to remember. Okay, so floating static route is also called backup static routes. How we will say this static route is backup static route? See here, see this picture, there is a branch router and there is a headquarters router. So between these two, there is one route here, one route here. Okay. So the first route is traveling with help of private WAN. You can reach headquarters from this branch via internet. You can reach the headquarters. Okay. So to reach from branch to headquarters, you have two paths. This is the path number 1. This is the path number 2. But technically, they will say this is primary path. This is the secondary path. Okay. So how we will decide this is the primary path and this is the secondary path? Okay, we will decide this one based upon administrative distance. Okay, see here, based upon administrative distance, I can decide this is primary or secondary, or this one is primary or secondary. That is the first one. We'll see in the next slide how I'm going to demonstrate how we are going to use administrative distance. Okay, the second one is for example, we have two paths. The primary path is working. At that time, the secondary path automatically in disable mode. The primary path fails, only the secondary path is going to enable. Okay, I'm repeating. Primary path is the best path. Always it is working. Instead of primary path is failed, that time only the secondary path is going to enable. Up to that it is disabled. Okay. Now, this is what the flow. This is called floating static route or backup static route. Okay, see the example here. From R1 is connecting with this 10 network. Same example before we have taken. R2 is connecting with this network here. See, from R1 to R2, we are provided the redundant WAN links. Okay, so this is the first WAN link, that is 10.10.0/30 network. It is connecting from serial 002 to serial 001. Okay, I am assigned first IP here, second IP here. The second one, the redundant link is, the second WAN link is this one. So from serial 001 to serial 000. This is redundant WAN link. Okay, for that I'm going to use the network 20.20.20.0/30. Right? So these are the two WAN links we are used. Why we need redundant links? For example, this link is failed. We can the data will transfer via this route. Okay, so now there are two routes to reach from R1 to R2. This is the first route or this is the second route. How we will decide this is primary path, this is secondary path? At that time, the administrative distance is coming to the picture. Okay, so this is the primary path, this is the secondary path. This secondary path is also called the backup static route. Okay, so the secondary path is also called backup static route. Okay, or floating static route. Okay, so floating or backup static route. See here. Now I'm thinking this link is a primary path. I told you for any static route, The default administrative value in Cisco is how much? 1, right? For example, if you are using the Huawei devices, the default administrative value is 60. But in Cisco devices, the default administrative value for the static route is 1. Okay. Here primary path is 1. See, now I am writing, I am at R1. I am connected with this network and this network. I don't know about this remote network. So from R1 I can reach this remote network. So I am writing the primary path. IP route 192.168.20.0, right? Slash 24 means 255.255.255.0. I can use the exit interface for this one, serial 000. This is the primary link. Okay, so serial 000, or I can use the next hop address based upon the question. Okay, so the next hop address is this one, dot 2 means 10.10.10. How much? 2, like this one. See, after this one, you can write administrative distance value 1, no problem. Okay. See, for example, I want to go back to the topology. Just I want to demonstrate here. For example, I'm writing here IP route, okay, 0.0.0.0 to 0.0.0.0. For example, serial 0/0/0. Then I can give 1. This is the default administrative value. See here, if you don't give also, by default it is 1. Okay. See, for example, this static route, you are not assigned anything. By default, there is 1. There is 1 here. If you want to give 1, also it is correct, because the default administrative value is 1, like that. Okay, that is what the primary path. Okay, so back here. So this is the followed by serial 000 space 1, but mostly for we are not going to assign 1, okay, because by default it is 1. That's why we are making it empty. Okay, but if you go for the secondary path, check here, IP route to reach this destination 192.168.20.0. This is secondary path or backup path or porting static route. Okay, slash 24 255.255.0. The exit interface here is serial 0/0/ how much? Serial 0/0/ how much? 1. And in exam, they will provide what is the administrative distance value you have to give for the secondary. For example, I am given the administrative value is 5. Just you can write serial 0001. How much? 5. This 5 is administrative distance value. Okay, I'm going back to the packet tracer here. Going to the router. For example, I'm giving here, okay, the same one, serial 001. Imagine, just for understanding, 5. Okay, it is correct. Okay, see here. Here the administrative value is 1. Here the administrative value is how much? 5. This is the primary path, and this is the secondary path. So how you will understand this is primary, this is secondary, based upon administrative distance value. See here, the primary path administrative value is always less than secondary. For example, this is 1, this is more than 1, 2, 3, 4, 5, anything, but it is more than 1, then only it is the backup route. Okay, that is the logic. Okay, see here, for example, by default here the value is 1, here it is 5. So this is how we will discriminate which one is primary path, which one is secondary path. The highest administrative distance value, it is the secondary path. The lowest administrative distance value is there, that is the primary path. So in these two configurations, this is the primary path, because here the administrative distance value is 1. This one is the secondary path or backup path or floating static route, because the administrative distance value is 5. So if this link will fail, automatically the packet will travel to like this one. This is the background and how to configure the floating static route. But I'm not going to demonstrate now. In our webinar, I will show you how to configure this one and how to check the output also. Right? Now I'm going to the next one. The theory for the floating static route. See here, another type of static route is floating static route. Floating static routes are static routes that are used to provide backup path to primary static or dynamic routes. Floating static route is only used when the primary route is not available. See the point here. The floating or backup static route is only used when the primary is not available, means the primary route is failed. Floating static route is configured with higher administrative distance than primary static route. So this is what I am telling you here. Always the secondary path, or you can say the floating static route value administrative distance is more or greater than the primary static route. Okay. So this is what the floating static route is configured with higher administrative distance than primary static route. Okay. By default, the static route has administrative distance of 1. That is what I told. Okay. That's all about this one, the floating static route. Now we are going for the last concept here, 15.5, configure static host routes. Okay. As I told you, this one is not available in the previous curriculum version 5 and version 6. Okay. They introduced this one in version number 7. Okay. So how to configure the host? Before we configured up to now all for networks. Okay. Remote network. We are talking about remote network like that. Okay. Now we are going to talk about directly. We are going to talk about remote host. Okay. So how you will reach a particular host remotely? That is what the remote host routes. See, generally, if you go for basics, the IPv4 address of any host is 32-bit, and IPv6 address is 128-bit. See here, the host routes are how many types are? 3 ways. Host routes can be added to the routing table. So in 3 different mechanisms, the host route can add it to your routing table. Okay. The first one is automatically installed when IP address is configured on a router. Now I will show you this one. Okay. See here, for example, if you go for our topology, this is the host. This host is connecting with router number R1. Now I am going to the router number R1, right? And enable. See here, this interface is directly connected. This is automatic. Show IP route. Right. See here. What is the interface? 172.16.3.1. See here, 172. How much is this one, right? 172.16.3. How much? 1. This is what we can say automatically added into the routing table entry. See here, this is the routing table. Show IP route command. In that, these routes, you are not configured anything. This is automatically learned by the router which one is directly connected and locally connected. Okay. So this is what the local interface here. For example, this network, connected network. So 3 network. This is also automatically learned by the router. That is what they are telling. There is automatically installed when IP address is configured on the router. This is one mechanism. The second one is you have to configure a static host route directly, like before we did for all other types. Same like that, you have to configure the static routes. The last one is host route automatically obtained through other methods. Okay, but discussed later in this course, but they didn't discuss. Okay, so there are this third method is not there. Okay, so totally we are going to learn only 2, but the first one is automatic method because no need to configure, automatically it is going to learn from everything, right? So coming back here, the first one is automatically installed host routes. Cisco IOS automatically install host route known as local host route. Okay, when an interface address is configured on the router. Okay, so when the interface address is configured on the router, that is what I am telling here. For example, this R1, right? For this R1, right? This interface is automatically added to the routing table entry. Okay, so this is the local interface. This entry is automatically added. So the code value C, L, all these things comes under automatic directly connected networks. Okay, so if you come back here, So the Cisco IOS automatically install the host route, also known as local host route. Like example, an interface address configured on the router. See the symbol C means directly connected. The local routes means L. This comes under automatically installed host routes in the router. Go for the next one is static host routes. This is like static routing. What we did before, we had to configure the static route manually. Okay, so the static route uses the destination IP address. See the very important point here. Before we used network address and subnet mask. Here we are not going to use the network. Destination address directly IPv4. We are IPv6. We are going to use the destination IP address followed by we are going to use the subnet mask value is the full, that is 255.255.255. We have to use the full length subnet mask. It means it is a host route. Remember, you are talking about a host, you have to give the full length subnet mask 255.255.255. For IPv6, by default, we will use the prefix length /64. But if you are writing IPv6 host route, the prefix length should be /128, not /64. Please remember this one also. Here, /128 is prefix length for IPv6 host routes. So if you want to configure the static host routes for IPv4 and IPv6, if you are configuring for IPv4 or IPv6, you have to give the destination IP address, but the subnet mask is the full 255.255.255. From this, we will identify this is a host static route like this one. For IPv6, the prefix length we are going to give /128. Okay, that is the host IPv6 static route. Okay, now I'm going to do the example how to configure the static host routes. See the context here. There is a branch connecting with ISP. In ISP, there is a connected with the server here, right? So first understand the server IP address. The server IP address here is 209.165.200.238/27, and the IPv6 address of the server is 2001 BB8 ACAD 2:238. This is the IPv6 address /64. So we are assigned the IPv4 address as well as IPv6 address to this server. Okay, this is not networks. Okay, remember these two are the IP addresses for the server. IPv4 address for the server as well as IPv6 address for the server. These are the subnet mask value here. This is the prefix length here. Now I am at branch 1 is connecting with WAN link. Okay, so serial 010 like this one, and I am going to use the dual stack networks here 198.51.100.0/30. In that, the first IP I assigned here and the second IP I assigned here, as well as I am going to use 2000 IPv6 network global unicast address here 2001 BB8 ACAD 1:64. In this IPv6 network, the first IP 1:1 I assigned for here and 1:2 I assigned for ISP. Right. Now, imagine you are at branch here. Think that you are at branch here. Okay. Now I am at this point. Okay. I am at branch here. Right. From branch here, these connected networks. Okay. I know because I am directly connected with this network. You are directly connected with the server? No. This is the remote. Okay. This is the remote networks. Okay. So from here, directly connected, but this branch router doesn't know how to reach the server. For that, we need to configure the static routes. But what type of static routes we are going to configure? The static host routes. See here. For example, I am this branch. I want to reach this server. This is the IPv4 address. Okay. So I'm going to write the syntax in branch router. See here, branch router IP route. This is the IPv4 address of the server 209.165.200.238. This is the not network. This is the IP address, IPv4 address of the server. Okay, 209.165.200.238 slash 27. That is the subnet mask value. That means 255.255.224. But we cannot give that one because this is the host static route. That is what I discussed before earlier. You must give the full length. Okay, that is 255.255.255.255. Remember this one. Okay, if you are writing the host, it is fixed. Okay, if you are writing for host, the subnet mask value is fixed 255.255.255, and you can give here either gateway or exit interface. I am giving the gateway address here is 198.51.100 point how much 2. So I am at here branch. I want to reach this one. This is my gateway here. Or next hop address is 198.51.100.2. That's it. Okay. Now how to configure the host IPv6 static route. I am at a branch. I want to reach this server IPv6 address. Okay. So IPv6 route 2001 DB8 ACAD 2:238 up to here. See here. Before we will go give /64. This is the /64 prefix length, but we cannot give /64 in host routes. You have to give here /128. Okay, remember /128, and followed by the next hop address here is 2001 DB8 ACAD 1:2. So 1:2. That's all. Okay. So this is how we will configure the host static routes. Okay. This one also I am going to demonstrate in our webinar how to configure the host static routes in packet tracer topology. Right. So there are some verification commands are there. Okay. So how to verify the static routes? Show IP route. It is one command. Show IP route static. If you do this one, you can see only the static routes. Show IP route network is one more command. If you want to see a particular output, show running config pipe section IP route. I told you in the previous video also, section I think is not available in packet tracer. Okay. So show IP route, show IP route static, show IP route network like this one. But most popular commands is this one, show IP route and show IP route static. This is for IPv4 verification commands. Okay. But for IPv6, how we will verify? Replace IP with IPv6. That's it. Show IPv6 route. Show IPv6 route static. Show IPv6 route network. Like that. Okay. So show running config pipe. Okay. Section IPv6 route. Okay. So this is how we can verify for IPv4 and IPv6. Okay. Now, so if you want to verify IPv6 router, you can do the command show IPv6 route. Okay, show IPv6 route begin is there. Okay, begin gateway. Which routes are begin with gateway address like this one? You can verify particularly this output. Okay, and show IPv6 particular IPv6 address network. You want to check? You can check it. Show IP route static. If you do this one, you will see only the static route, not all connected direct networks. You are not going to see. We have already tested this one also, and this one IPv6 route static. You can see only the IPv6 static routes as well as that's what. Okay. Finally, we are coming to how to remove the static routes. Okay. For example, you learn totally different types of static routes. Okay. Standard static route. There are two types. The first one is recursive or next hop static routes. There we are going to use the next hop address or the gateway address. Okay. The second one is directly connected static route. In directly connected static route, we are going to use the exit interface. Okay. The next one is the default static route. In default static route, based upon the question, we can use either next hop or exit interface. The next one is fully specified static route. We are going to use both exit interface as well as the gateway. The next one is floating static route. Floating static route is also called backup static route. How we will discriminate the floating static route from normal static route, because the normal static route, the default administrative distance value is 1, but floating static route, the administrative distance value is more than 1. The last one is we learned the host static routes. Okay, for the host static routes, if it is IPv4, you have to write the route for the destination host address as well as the subnet mask value is default. You have to give 255.255.255. That is full. And for IPv6 host route, we have to give the prefix length is /128. Okay, that is what you learned. And there are different verification commands: show IP route, show IP route static, show IP route network, and by using pipe, if you want to see particular section of output, you can verify also. Finally, we learned also the packet tracer topology, how to configure the directly connected and recursive as well as default static routes. If possible, if you have time, please design the topology by your own and practice it in home. Okay. So the last one is how to remove the static route. For example, by mistake, you did something like 10.10.10. Actually, 2 you have to do. You are given 10. So how to remove the static routes is you have to give the command no. No followed by the full IP route. For IPv6 also same. You have to give the full IP route, but in front of that you give no. It will the IPv the static route is going to entry removed from the routing table. Okay, so this is the point here. If you want to remove the routing table static routes from routing table entry or routing table, you have to give the command no full route. Okay, IP route, network, subnet mask, gateway, or something like this one. No IPv6 route, prefix with prefix length, and exit interface. All so remember you have to put no in front of this one. Okay, how to remove the static route. That's it. That's all about this chapter. Thank you. Thank you so much for listening.